Today's presentation is about Inventus Power and batteries 101. So who we are is Inventus Power. So agenda is what is a lithium-ion battery pack, chemistries of lithium-ion, and the next generation, safety and battery management. We're going to also talk about U-Life medical batteries, which is already designed for medical applications, and a little bit about Inventus Power. So what is a battery, a lithium-ion battery pack? The anatomy of battery packs, it's a typical rechargeable battery consists of four major elements: the batteries or the cells, which you see here, and then a packaging, which is a plastic casing or shrink wrap, interconnects, and a smart electronics. What is a battery, or the cell actually? Every cell, regardless of the chemistry, consists of the following elements. You've got two cathode materials, anode and cathode. These are electrolyte, and then the electrolyte where the ions transfer, and then the separator to keep the two from shorting. Of course, the separator ensures that there is no connection between the two materials, and then the electrolytes is used to create the oxidization or the transfer of electrons. And then the electrons flow, you get power, and that's what powers up your device.
So, just based on your materials that you choose for your cathode and anode is going to drive the power of the battery. Does the separator have any, and the electrolyte have any impact on the battery power?
Everything inside the battery impacts the capacity, the safety, and everything. Actually, there's a few slides that will show the differences, and we'll get into it a little bit more than the architecture. But this slide is only to show you what a battery consists of. So the lithium-ion versus other chemistries. Where the strengths are: energy density, higher cell voltage. If everybody knows the old NiCad and nickel metal hydrides, 1.2 volts. The lithium is in the 3.6 and 3.7 volts, so you see actually it's 3 times the voltage. Better cycle life, lighter weight, reliable charge and discharge, performance, and lower self-discharge and longer shelf life. And what all that means is better cost, total cost of ownership. Then the challenges are basically it requires electronics. And I don't know if that's accurate, because even the old NiCad and nickel metal hydride and lead acid, they still put electronics and therefore fuel gauging. So adding a safety circuit, it's a small challenge. And then the upfront cost of developing lithium-ion versus just buying an NiCad or an alkaline. And then the impedance, the internal resistance of the cells themselves is a little bit higher. Classes of lithium-ion. You were asking about the chemicals or the cathode. So without going through chemical engineering 101, basically the cathode, there is the cobalt, the NMC and NCA, the mixed metals. The energy comes out of depending on what the selection is. The power capability, the energy, it depends on selecting the chemistry for each one of these materials. So the anode usually is graphite or hybrid. There's the silicon. There's a lot of stuff going on the silicon to increase the energy density. And then, well, obviously, like the capacities range from 2 amp hours to 3.45. And then we're talking here like capacities of a cylindrical 18650 cell, and we'll show the 18650 cell, the form factor. The maximum discharge rate usually is 1.5 C for those chemistries, almost 2 C rate. The C rate is the capacity of the cell. The charge voltage is up to 4.35. That's why these cells exhibit higher energy density. Then the higher rate cells or the mid-rate cells basically are used in power tools or devices that are hungry for power, and they range between 1.3 to 3 amp hour capacity. So the less capacity, the trade-off is you get less capacity, however you get more drain out of these cells. Mid-rate cells are becoming actually more popular, and we'll show a slide where they're starting to dominate over the energy cells. because they give the power and the energy density, and they're safer, inherently safe. The new sizes are the 2650, 2700, and 21700. And we'll talk about these sizes. They're basically bigger diameter and longer cells.
So change from a high rate to a mid rate, is that changing the cathode and anode material?
That's correct.
Okay. And that's got to do with electron transfer between cathode and anode.
Yeah, the material itself, the electrolytes, everything is structured differently for higher power cells. So here again, we're talking about energy cells, a lot of cobalt. Cobalt is the dominant. And then the mixed oxides are where the power cells and the mid-rate cells. The phosphate usually is a power cell, but they're making now the energy version. They're inherently safe. They're still lithium ion, but they're phosphate driven. So if you look at actually the cobalt being capacity where you at versus the mid-rate cells and the phosphate cells. And then you go down the voltage, it's almost the same for these two. Phosphate is lower. Internal resistance is the lowest in the phosphate because of the way everything's like trade-off, the capacity, resistance. And then we're talking about the energy density. The highest are the laptop type of 18650s. The mid-rate cells are actually starting to reach the capacities of the energy cells. The phosphate is still the lowest in capacity. The discharge rate capability is the highest for the power tool cells and the phosphate. It's kind of like inaccurate because some of the high power cells are already at 10C rate. And then the self-discharge, the lowest is the phosphate. The cycle life, the best is in the phosphate. But some of these cells, the mid-rate cells, if you lower your voltage and treat the application range within the specified limits, you actually can compete with the cycle life of the phosphate. And then, I mean, these are the suppliers, but there's other suppliers that we deal with.
So when you're saying cycle life, that's the number of times that you can charge to discharge?
From full to empty. So if you did a shallow discharge, that's not considered the full cycle. You have to put in a full capacity and take out a full capacity. Okay. That's considered one full cycle. Cell types, polymer pouch, which is basically like an aluminum foil package. They seal it in a way the tabs usually exit from the front. And then the button cells, a metal can prismatic, and cylindrical. So what's the advantage of a polymer? If you're looking at 3mm or